Hello. Today we're going to continue the last lecture, which means we're going to upload the file we save, and then we are going to talk about the data and in some statistics. Before I do that, I'm going to show my library, which means that I have to choose some package that I will going to use with the data I'm planning on. The first two libraries here in my scripts are for data manipulation. They are very good, and I advise you to have them when you're working with. The others libraries that I have, they are about graphics, okay? Especially the ggplot2. We're going to use it almost every time. So I'm going to start, and then I'm going also to set up my work directory. Okay? And then I will load my file. You remember that the file we saved has 13 variables, and then as I show here, the PE test has 72,419 observations, which means each observation is a student, and then the student has a grade for Portuguese and mathematics, which are numerical, and then we have some scalars that we put it as integer, and then we have a dummy variable and 5 variables for coding. I'm going to do a small summary about the variables and about the file. As you can see here, we have the 13 variables, and we have the minimum, the first quarter, the median, the mean, the third quarter, and the maximum value. Why do we have the first and the third quarter? Because the difference between them is called the interquartile range. It means that most of the population are in between them, and it will help to do the box plot and the whiskers. It's a way to show the outliers. We're going to see it when we are going to do the graphics. Okay, and let's talk about the data we have. Imagine that I want to know if one of my proposal is to check if the average in Portuguese or in math it is greater if I'm in a public school, in a municipality school, or in a state school, or in a federation school. So that's why I have this code variable, so I can divide it by students and see if it is true. Okay, and the dummy variable, I could ask if is there any difference for the grades to be greater when you live with your mother. So I'm using the LM variable, which is living with my mother. All the code variables could be used with cross table with the variable, the numeric variable. If I want to see any changes, I could check it with a code variable. And I also could cross table variables with my scales. Means that if the student live far from the school, does it influence the grade? And then I have to check it. So in order to study my data, I need to have some cross tabling, and that's what we're going to do now. Okay, and to start, let's see how the students are divided. How many students do I have by administration, for instance? So I'm going to table administration, As you can see here, I have 306 municipality students, 82 students in state schools, and I have only 31 students in federation schools. Okay, what does it mean? It means that in Brazil it represents that the through law, because by law the state must have the high school students, because I'm just studying the high school grades. Okay, but I also can determine geographically where are my students, and then I have 5 regions with some meso-regions here in Pernambuco, and they are divided by 1, 2, 3, which I have the names for them, and if I want I can change it meso by any meso, and then I have the regions by name. I can see here the names of the meso, the areas, the regions I have, and then here the number. As you can see, the metropolitan area of the capital has almost a third of the students, which is 27,000 students are in the metropolitan area. Instead of using the numbers to code the regions, I can use the name to code the regions. Okay, but can I see it, the same data, but across table, how the students are divided according to the administration and the region that I want? Of course I can. I can put it in table 1, and then as you can see here I have the result, which means the municipality has students in area number 1, number 2, and number 5, and the federation only has in one place, which is in the 31 students are in area 3. Can I save it, this table? Because the way it is in table, it is not in a data frame. Can I save it as a data frame? Because I can keep it and then I can interchange with another data set. So I put as data frame, and as you can see, we're going to have a problem. See, it puts one column on the top of the other. For instance, for area 1, I have 1, 2, 3, 1, 2, 3. See, it doesn't keep it as a data frame that we used to see here. So we have to change a little bit in order to have it as it is here, to do a cross table, a proper cross table. So to do so, I do a second time, which is table 2K, and now I have it. But I have to change the column's name in order to have it related to my region. The most important thing is that I show you how to cross-table codes, variables that are scales or code. And I can change it so I can know about probability for one student to be in one administration regarding considering that he is in one regional area. Okay, so the most important thing is that you can now do crossing table either with table or F table. Okay, now we are going to move on to plots. I want to know about how my students' grade are they concentrate in one area, or are they very spread? Do they have a center, they don't. So I'm going to use a histogram to see my data. Okay, so I'm going to use a ggplot, but you can do it in lattice too. We're going to see later. So let's do the grades for Portuguese and see how they are dispersed in my um, grade scale. Okay, so here we have about 500, 5,100 some students here on top, and they are distributed in 30 bins, which means 30 scales here. It is the R did it by itself, but I can change it. I can change the numbers of beans. That just put it here. Beans equal to 15, and see how it works. You see, now I have only 15 columns, but I'm gonna keep it there. And I also can change the colors of the bean. I can do the best thing is to put some titles and captions and see how the graphics is going to change it. But let's see another thing. Let's see about the middle of my grade, which is the mean and the median. And not as the summary did, because the summary didn't keep it. I want to keep it the number. I want to keep it how is the mean, how was the mean grade for my students. So I'm keeping it for Portuguese and math, and I'm also going to, if I want to keep it the average for each area or for each administration, and so to see how my grades are divided between administration. Do state has the higher average, or are they different? So in order to keep it by administration, I just use it Tapley, and I did the variable that I'm going to use it, which is the grades, and by administration, and what I want is mean. Okay, so I'm doing the average, and I want to see it for region, for administration 1, which is municipality. I have 329 for the middle, the average grade, and for the state and for the federation I have here. Are they different? I don't know, but I can check it now because it's keep it, and it's keep it has numbers, but I want to keep it as a table data frame. So I use MD data frame, as you can see here, the average for 1, 2, and 3, and then I can keep it and do some exercises later. Okay, says that I have 50% after and 50% of my students later. The average, it is it's balanced by the weight of each grade. The median is just the division between the number of students. If I have 7, the mean will be the 4th observation. Okay, so I'm gonna ask for the median for Portuguese and for math, and I also can keep it the standard deviation. And why do I need the standard deviation? Because considering that my populations is almost normal, it's like a bell, okay? So if I position in the middle plus a standard deviation, the center is the average plus one standard deviation, and the average less one standard deviation. In between these two, the interval between those two numbers, I'm going to find 68% almost of my students. So it's good to have the standard deviation, and I'm going to keep them, and I'm going to plot the same one with 30 beans that I plotted before this, but I'm going to add some title here and the captions and what is each X here. Okay, so but I also plot something else too. Let's have it here. Okay, here I have a histogram. My data is from 2019. Is a SciAb data, which is a huge data bank, and I have the grades, and I have the frequency, and I have also add the blue line is the average, and the red line is the mean. I could also put the names here, but these, I can see that this bean here, which is this column here, has both the mean and the average. But I want to see it not as beans, but I want to see a density, frequency, a relative frequency. So instead of doing a histogram, I'm going to do a density plot and also plot the average and the median. Okay, so it is the same command, but instead of using histogram, I use a density. Here you have, and I put it in red. As you can see, is almost continuous, and then I can also add the mean and the median. Okay, here we can have it, and then I can export this to any Word or any word processor that I have. Another way to see the histogram, let's say I want, instead of one graphic about Portuguese, and I want to put it two graphics in the same graphic. I have a command which is par, and then I can cut my graphics in columns and lines. So I'm going to say that I have two lines, which means Portuguese and math, in one column. Okay, and then I have to say where to start plotting my graphics. Let's give you an example. Right. See, I have in the first graphic, I have the histogram of the one I saw it before with 30 beans for Portuguese, and then I have for math, and I have all the grades here. So I can compare in between graphics. Okay, it's just another way to see the graphics. And I also can do it with the density function. Instead of doing with histogram, I'm going to do with density function. But I'm going to put it inverse because they are very similar. So I'm going to put on the top, I'm going to put Portuguese, and looking backwards, I can see math. Okay, here you can see this is a Portuguese, and here is math. I can also put a title here and another title here, saying here is Portuguese and here is math. I can also add the lab here the same way that I did it before with the density function and caption and so on and so forth. Okay, now let's try another way to see. Instead of see one on the top line, the positive, and one in the bottom line and the negative, let's try to put one farther than the other. Okay, so I have this special library, which is the ggreach, that does exactly this. But in order to do that, one of the variables must be the name of the grades I'm using. So instead of using a column and another column, I'm going to put one color on the top of the other and named these lines, the grades, with the lines that are for Portuguese and the other set of the lines with math. Okay, so I have to melt one column on the top of the other, or I have to gather, and in order to do that I have to use this library reshape. Okay, so I'm using the library reshape and I'm going to gather these two columns, color number 4 and number 5, which are the grades of Portuguese and grades of math. And I'm going to see what grades are. See, here it says, the key says grade for Portuguese, and after 7 to something, I'm going just to the down, and I see the grades for math. So one color is on the top of the other. You see here I have two variables. One is the key, one is the value, and I have the double of observations. So grades, that's okay. And then I'm going to plot Portuguese and math in just one graphic and just a little bit switch a little bit each one. So I have grades, and my X is value, my Y is a key, and I'm gonna color it as key. And it's called geodensity reach because we're going to be doing one on the one on the front of the other. Okay, and the legend position and the labs and everything. So you can see my labs is a density function that's for Portuguese and that math, and the grades, so I can see both density function. I can also plot the average, which is where is the middle considering the weight of the grades. Here I used another set of information for you. Is the kind of the line, one is dashed and the other is two dashed, so they follow the color, but they also different between the kind of line I have. And then I'm going to finish because I believe that we have lots of information. What we have done today, we have first upload the file, and then we had obtained how to do some table with the codes, and we have learned crossing tables with the variables. We learn how to do histogram, density function, and we learn how to do two graphics on the same page, or two graphics, one on the side of the other, on the top, on the bottom, and then one skipped a little bit from the other so we can see both density functions. I hope you enjoy, and thank you.